where we've been working on it for many years, and our goal that whole time has been about moving the world's economy, all the ways that people cooperate online onto the decentralized web in a way that they can cooperate safely with more people. And so the focus of doing that, or our technique or our technology or our approach for doing that, is enabling the millions of programmers out there to be able to build large-scale decentralized systems and smart contracts safely and easily. So we basically can't take over the economy until all of the programmers out there can do this stuff. So we've built, large-scale payment systems, have built brokerage systems, have built, large-scale information systems, and are core members of the JavaScript committee, which is relevant because the system that I'm going to show you today, the systems that we're building, are in a secure subset of JavaScript so that all the, 80% of the programmers in the world have a chance of understanding and building it. So first, what's a smart contract? Because that's an important element, and when we go and talk to people, they have very different ideas. All the time that we've been doing this, here's our definition, right? A contract-like arrangement, not an ink contract, but a contract-like arrangement expressed in code where the behavior of the code enforces the terms of the agreement. So this is, a workflow across interests, businesses, people that are where the orchestration happens because of the execution of software. And that's really valuable, but it's even, and it was really valuable 30 years ago when these ideas were first coming together, but it's even more valuable when you add blockchain in. Our view of blockchain is it basically introduced new machines built out of agreement rather than out of silicon. So what that means is when Ethereum first came out, right, it was a computer about the power of an old cell phone, but with vastly higher integrity. Right, with vastly higher assurance of correct execution of the program. Now, when the program that you run is one that is enabling cooperation and enforcing rights transfer, that's something that you really want to run with high integrity. You really want to be able to just directly trust its execution without having to worry about who happens to be running it. And that's the thing that these computers built out of agreement and spread across administrative and sovereignty domains, that's the thing that they enable. But our model of doing smart contracts was about cryptographic protocols between machines. So when we added these new kinds of machines, the model can work in them and stretch across them. And so it's about being able to build interoperable systems. We have a compute model that works in a variety of environments of these green islands of sequential transactional computation, the simple event loops of browsers or Node or we've seen the same kind of implementation in C# and Java and Tickle and all sorts of languages. But they're connected with asynchronous messaging and sort of this asynchronous sea of the world's computation. The world does not function in a synchronous fashion. Activities are happening in lots of different countries. Being able to easily orchestrate sending asynchronous messages back and forth enables larger, faster, more scalable systems. We build that into we produce that in an object-oriented environment for programmers where they can build simple objects using their simple familiar programming techniques that can orchestrate with each other securely between these different containers, which we call VATs, by the way. So in our system, that's in a secure subset of JavaScript, but there are lots of systems that are looking at using WASM directly and other languages built on top of that. But it allows us to do both simple programming within these VATs and then asynchronous messaging for large-scale orchestration. Above that, and finally sort of the final layer of the stack, or maybe there's the political layer and everything up from there, but the final layer of the stack that we implement is our contract layer. So the world of software, the world of building fancy web pages or what have you, people are used to being able to build that not by starting from scratch each time, but by being able to go over to Stack Exchange and do a search and find out, well, how do I do a scrolling panel of pretty pictures, right? And I don't have to implement JPEG, and I don't have to implement scrolling panel. I just go, learn this, pick up this component, place it in my application, and I'm done. And I can go on about building my art auction or whatever it is I'm building. Well, we want the same thing for smart contract components, and so that's what we provide. And so the layer above this is escrow agents and monies and auctions and futures and forwards and and all those kinds of components that you'd like an expert to get right once, and then you reuse it to put together your comparative advantage and enable your cooperation using these mechanisms that other people built. So that's the stack that we're building, and we have things that we're doing across that whole spectrum. But I know what you're thinking, however, which is, where the heck is the coffee? But before that, where does privacy show up in here? And I'm not going to talk a lot about that because we're still early in the implementation of this, so we're getting just to the testnet stage. But that's the thing that is so important in this community, is getting that, that sounding board. So when I say where's the privacy in here, I'm going to want that feedback over the next year or so of where are places we can use the magical technology of zero knowledge and put it in here and that sort of thing. But the place where our architecture gives us the ability to do interesting private things is simply that it is uniform across public chains, consortium, private chains, and individual machines. So I can have one of these VATs running contract components on here, talking to my machine at home over secure protocols, that is then talking on my behalf to a consortium chain, accessing resources on a public chain, turning around and using monies that it brought over from Zcash or other networks. And so we give an easy ability to run in private domains. We'll be wanting to, in our future roadmap, start to add other technologies like the stuff that we're seeing in the much more technical presentations here. But there is a thing that comes up given where we're at, which is, there we go, which is, we're at testnet stage, so I'll be showing that, and I'll say a little bit more about that in a moment. But so we've been going out and talking to reference partners, and we'll be looking for people to work with where, as we finalize, as we develop more of the stack, we can go out and work with partners to actually help them build their application on our system. And, sanity test, you never want to do an API without having a real use of it, because otherwise you'll go off in space, right? So when we're always asked, what are the use cases? Why would I use blockchain instead of a database? Why do I want to do this decentralized thing? All that sort of stuff. And there was a group of economists from RMIT University in Australia, and they had a fabulous, a great description of why that is. And it's that blockchain and smart contracts on blockchain differentially reduce the cost of trust. They make it easier to establish new kinds of trust with people that you could not necessarily cooperate with before, or that it was very expensive to cooperate with before, or those kinds of things. And by cost of trust, we mean all the procedures, all the processes that you use in order to have a relationship, do some cooperation, and feel safe about it. And so one of the things there that they did not cover, that I will note, is significant areas of privacy, which is as also important. And as I hear from Zuko, and I'm sure lots of other people also repeat, commerce needs privacy too, right? And so, but when they did this study looking at where do people spend money, where do organizations spend money, and it was a broad world economy study, they found that upwards of 35% of the GDP is spent on protecting value rather than producing value. It's spent on making sure it was safe to have that arrangement with this person you don't know, rather than simply enabling you to connect to them and go forward and make something happen. And it's not that we're going to get rid of that 35%, but that's $30 trillion of value there, that by being able to reduce the cost of that, we get lots of opportunity for businesses, lots of opportunity for new cooperation, and we enable new structures and new ways for people to cooperate, do business, share things, etc. And so that's true of blockchain, and again, added to that is true of being able to have the zero knowledge things that give you yet more power there. And just as an extra added data point, we were looking at the freight industry and looking at use cases there, and the World Economic Forum identified that just the very lowest hanging fruit of getting chain of custody onto a reliable system where, when someone says, yes, I handed it off on that date, I don't have to investigate, I don't have to do reconciliation, I just know it to be true because I can see it in this high integrity ledger. Just that would raise the global GDP by 5% and increase world trade by 15%. So these are huge numbers as we get this stuff out into mainstream. And so a lot of Agoric's goal is to get this stuff out into mainstream. So where are we at? We started last year just before ZCon 0, and so in some sense we announced we talked about our secure kernel for being able to do fine-grained compartments there. And since then, that's now underlying the Salesforce platform, so 5 million developers are building stuff in their app exchange where the security kernel that we built for doing smart contracts is providing security in that environment. MetaMask, just at the Cosmos Hackathon yesterday, finally put together, Aaron Kamovas finally put together the integration of SES into their build structure so that applies generally, so that if you've got a large JavaScript project, you can have our secure ECMAScript wrapped around all your safe modules. Node.js is integrating this. The IoT Standards Committee for JavaScript, TC53, is actually standardizing on our secure subset of JavaScript as the JavaScript for embedded devices and embedded systems. So that's made a lot of progress, and it's actually having a security impact on the outer world, on the mainstream economy on Web 2. So thank you for people for helping us make that happen. So where we're at today, and this is sort of the most exciting part today, is we're now at testnet. So we've been building our part of that whole stack, and we've now got a live testnet up on the internet with a few people starting to poke at it. Now it's private. It's not, it's invite only. We're going to gradually be growing this, and of course, continually enhancing it, adding it, making it more accessible, making it more exposed. But all of the code is open source, available on our GitHub repository. We are a testnet where we don't, our primary value is the stack on up. So we built our system integrating with Cosmos SDK, so using Tendermint as the consensus algorithm underneath. But again, the design is very portable across different infrastructures. So as we go forward, possibly after we get to mainnet, we'll be adding more and more of these networks to be able to provide the same kind of infrastructure. So Polkadot integrating as much as we can with Zcash and Bitcoin and Ethereum and so forth. So what comes up next, just real quick, we're working with the inter-blockchain communications protocol folk, Chris Go, Zucky, wherever they are, the Cosmos and ICF folk, and so we'll be working on that for interop, and our system, our communication layer of asynchronous messaging, will rely on that directly. We'll use that directly. And then finally, these iteration of testnets will be adding more and more up towards the contract framework, which we have in the current system. We have a early primitive 0.2 kind of version. And then finally, of course, we will go to mainnet. And when is ZCon 2? Since I'm sort of having these yearly, I'm not promising when that is yet. Okay, so what did we build? Smart contract nano kernel. So this really does look like a user mode, system mode separation where we can run our VATs as approximately processes with the kernel that are orchestrating our security model, our object capability security model underneath, and enabling us to remote it as well, providing persistence and so forth. So that provides that featherweight compartments, the same kind of thing that is used in Salesforce. We're using it for contracts. And it provides the asynchronous messaging between them and gives us replicated, deterministic, approximately, execution of the secure subset of JavaScript. So we did the chain integration with Tendermint, and finally our initial rights transfer protocol. That's in order to have the testnet be a testnet of the entire stack, right? The goal is to get end-to-end everything working, and then you make each of these layers better, or, hey, we're open source. Anyone out there that wants to do UI framework for us, come talk to me, right? So we did our own UI a little bit in order to be able to exercise and be able to enjoy enhancing the testnet over time and give people some pace to play. So if you've ever seen the $1 million homepage where people have abstractions about or party on the pixels, we did something like that, obviously starting more modest, but each round of testnet, maybe we'll add another set of pixels here. But the key thing we did here is each pixel, there is a digital asset that is the right to update that pixel. And I can sell you that digital asset or exchange it through the escrow agent. I can build, there's distinct authority to color versus authority to transfer. We can build derivative assets, and so we've got a covered call where what's covered is the right to some pixels, not a stock or not a bond or whatever. It's the right to color some pixels. And that means that if pixels are randomly assigned, I can start to purchase calls to try and get together a rectangle so I could splat up my logo in a rectangle or something like that. And then there's a pixel faucet, so people in the testnet wake up not with any money, but just with the ability to buy some pixels, and then they can go sell them on the market maker in order to exchange them for, in this case, it's called pixel dust, So, and then of course it's extensible. Now I can go into a lot about how it will work, but I'll actually just show it here. But our UI, remember I said we did just enough, is display of the pixels and a read eval print loop, so I can just type JavaScript expressions. And since of course we have a secure subset of JavaScript, I can type anything I want and I can't bring down any of the system. But the architecture of our provisioning, and we have a secure provisioning thing that uses Brian Warner's magic wormhole interactions, is that we have a chain. You can see the chain over on the left. And for each of the users, right now it's not running connected directly to a browser, but it's you run a solo instance, our same engine running on a single machine, and that's able to do relay style IBC stuff to be able to talk to the server. And so I will jump over to, here's the real version. You can see I've got paint, I'm going to paint, see that blue pixel right up there in the middle? Yes, I'm going to go ahead and paint that red. Now, what's actually going on here is it's sending a message here. Actually, I just got the response. And, there's the whole bitmap. You can see, prototype, right, or early access. There's lots of layers of JSON encoding as we go through these various messaging stages. And here is the response saying, yes, I've got the answer, and so forth. So this is packaging up messages, sending it back and forth. The testnet servers are currently deployed out onto mostly DigitalOcean, but I think we're using multiple infrastructures, and they log their data up into a log server. So this is I'm connecting now to one of the log servers, but you can souls, and the messages go back and forth, doing blocks every time, and that pixel that was red is now blue, right? Is that what happened? Yes, there we go. So now this is not, this is an enormous amount of work to color one pixel, but of course what's really happening is the secure messaging, as I was saying, back and forth between these machines, where it's using all of the kinds of stuff that we do for cross-chain communication as well. And so that's our, if I go here and let me just, for Zuko's there, I will color it zebra, and we will see what that ends up with. And so obviously I could do a whole page of caveats here as to what's actually going on in terms of scaling, performance, and so forth. Each of these round trips has to wait for blocks, and the blocks are every 5 seconds, so that of course adds some real latency. But if I were to go grab here and color a whole bunch of them, you'll be able to see that that's not what I wanted to do. Oh, what I didn't do is, so I'll do that. Let me go to, what did you say? Yeah, I saw. Yeah, I didn't actually paste the, yeah. So first let me, in this case, I'm going to go grab over the faucet and get a pixel, and again, as you can see, where's the message went out over here? Here's where, whoops, stop, scroll down. So here's where the chain received that message. Where I just saw there it is. Received that message, tap faucet, and of course it goes into the transaction log. Now, one of the characteristics of all of this, this guy's not being helpful. Let me just terminate this here. That's the solo vat. So all of the chain nodes, all of the solo vats, I can just restart it. I don't need to pull it again. But I can just restart the solo vat. And again, all of these layers, every element is persistent. So the basic function, the basic expression of smart contracts is now it's doing quick replay to establish the state of the transactions all along. And this browser now is, I didn't show it before, as being disconnected. So this browser, you can see it knows its WebSocket is down, it knows it's disconnected, it knows it can't do anything. If I now just restart the service, this is my solo vat that's talking to the chain, but it's got persistent state of what it's evaluating. This now is back in business, and I can take whichever pixel that is, history 12, is that what that is? Yep, and I can color it to, here I'll use zebra because that's showing up. and it will send the message, here, that then is encoded, broadcast to the Tendermint chain. It comes into the Tendermint chain here, which writes it out into the log so that can be replayed when we start new nodes. This may not catch up. That then does the processing of the transaction, whether it's trading or selling or coloring pixels or what have you, sends the results back by writing it into the blockchain, into the transaction record. The relay service then scrapes that out inside of the solo vat, is watching those events, pulls it out, and will end up, when it sees that block confirmed, it will update the screen to show, or it'll query to get the new contents of this page. And over wireless here, it's a little slower than in my normal demo. But so this actually, one of the important things is that when I send a bunch of messages, they'll all go out in one block. Here I'm doing one round trip, so it's 5 seconds a transaction, but it would be 5 seconds for 10,000 transactions as well. So pipeline messaging and streaming is all part of the architecture. In this little demo, you don't see it. Oh, that's because I will. That's because I killed it in the middle of a message. I'll talk about it. All right. So I could have a page of. Hang on. I could have a page of caveats, of course, since this is a early version. But that particular bug just showed up 3 days ago, and I have no idea what's going on. Kate knows what's going on, but I'm several thousand miles away from it. So I said, don't change anything because I know what will work. So we will be rolling out new versions on a regular basis. In a couple of days that'll go away, and then we will have versions that start to be available where people can, pull requests. You can do your own contracts and we'll deploy them, building, games or applications that can grab multiple of these pixels in order to be able to do interesting abstractions or patterns or what have you, and then gradually making it available so you can dynamically deploy new contracts in the network and token models and all that sort of stuff. So that's what we have. It is now operational. You can go to our testnet site in order to put in your information so that as we start to add people or make it accessible, it's easy to contact you and get you connected in. And we look forward to seeing what you guys build with it. We look forward to hearing your recommendations on which things we should add first or which things you would like to see and use in the framework. So. Thank you very much, and I've got a few minutes for questions. And coffee's right outside, so if no one's awake, that's okay too. All right, thank you for your time. Here we go. Hello there.
You said something about determinism, and then you gave a caveat. Is that because it's fail-stop determinism, or is there a different caveat?
Oh, no. It's actually quite deterministic, and the goal will be full determinism with detailed specifications about that. We're working closely with the embedded systems group that cares a lot more about that than the normal JavaScript standards group. And so the kind of non-determinism is if you are iterating the keys of an object and a jitter happens to then jit your code in the middle of the operation, it could suddenly see the keys in a different order.
Oh, I see.
That kind of detail.
Okay, thanks.
So, Andrew, you were about to say something. Yeah, I've got time.
That example was just on one blockchain, right? The non-simple question is like, what would it look like to do escrow transaction like across?
So from the point of view of programmers, it would look identical. So the question, since he was in the mic, was that example was on a single blockchain, what would it look like to do a cross-chain system? Many of the elements of the protocol we have there work cross-chain, and our original prototype worked cross-chain. From a programmer's point of view, it would look identical. In this particular case, my solo vat was handing a resource, or there's other examples, handing a resource to someone in a different solo vat through this chain. That's exactly the same process if I was referring to